So I'm going to talk about iOS architecture at scale. And by scale, I mean millions of daily active customers. Customers, not users, customers. People that actually give you their credit card to buy stuff. And the amount of stuff they buy is worth billions of dollars every single year. So that's my definition of scale. So the app I'm going to talk about is for a very large e-commerce company. They're so large that I couldn't figure out how to get my slides past legal in time. So I'm not going to mention them by name, but it is mentioned in the description on the web. How large? I'm only going to talk about the product view because that's the team that I'm on. There's many, so the product view has the hero image, add to cart, the price section and stuff like that, and many other features. There are many other views in the app and many other teams. There's about 50 people on the iOS team alone. And there's dependencies on web services, and there's also like an Android team and a mobile web team that we work closely with. So how large is the app? It is almost 500,000 lines of code. And it's at the point now where there's actually more Swift than there is Objective-C. So there's been a multi-year transition to get there. There is a bunch of JavaScript in the app as well. This is because some of the views are built in React Native. That doesn't actually account for all of the code, all the React Native code, because they use a technology called code push, and a bunch of JavaScript actually gets injected into a container at runtime. So it's actually even larger than about 500,000 lines of code at runtime. So the product module, it's about 50,000 lines of native code, and also more Swift than Objective-C now. There's been a 3-year transition towards Swift, and most new code gets written in Swift. How legacy? Okay, so the app is 7 years old now. The original code was written in 2011 for iOS 11. Folks, remember iOS 11? This was before self-sizing table of view cells. This is before collection views. Collection views arrived in iOS 6. This is also before auto layout. So a lot of the original code was meant for static views that calculate rectangles and frames. Remember the old school way that we used to lay out views? So a lot of the design choices throughout the app, they still show. So there's a lot of legacy there. So if we want to talk about iOS architecture at scale, what we need to talk about is good architecture. And we need to agree on terms before we can even debate like the merits of what that is. So what is architecture? We can talk about files, we can talk about folders, we can talk about classes, we can talk about functions. But I propose that architecture is a set of decisions. So decisions may reduce the set of future decisions that you may be able to make. And this may be a good thing, this may be a bad thing. This is a good thing when it makes it obvious how views should be composed, how model state should be changed, how controllers should respond to actions, and how the app should navigate. This is good when code becomes like uniform and obvious. So how do we define good? Given a large code base, making decisions that turn a 50,000 line of code module into a 100,000 line of code module, probably a bad decision. Something that turns a 500K line of code app into a 1,000,000 line of code app, probably a bad decision. So I propose that good architecture is small and simple. You really need to simplify if you have an app that is that complex, that large. So Swift has features, so you want stuff like simple state mutation. So Swift has features that make state mutation simple and explicit. There's stuff like did set and will set, and this makes it clear and explicit how state is mutated. And if you have this uniformly through the app, other developers looking at your code have an expectation of when and where state gets mutated. Simple delegation. So delegation is a very common pattern in Cocoa. This is because it's fairly simple and fairly straightforward. Developers get it. So like notice that the delegate is a weak variable as well. So ownership is also simple and straightforward. So if you uniformly know that you use a delegation pattern in controllers or in views, and you always know to mark them as weak, and this is just a pattern that is uniform throughout your architecture. That's a decision that you have to come to with the team and decide, this is the kind of pattern that we design our architecture. Simple callbacks. And Swift closures also make callbacks simple and straightforward too. So notice the capture list. That's a feature in Swift that makes ownership also explicit, simple, and straightforward. So memory ownership is super key to understand and make explicit when you have that large of an app. Because if you have a memory leak, where is the memory leak in that 500,000 lines of code? It can be difficult, very difficult to find. So simple observation. Observation actually really improved in Swift 4. So the key path feature really reduced the amount of boilerplate that you have to write. And picking out a change value is very explicit and simple as well. Previous to Swift 4, it was not a technique that we used. This is something that we're adopting as well. It's also very simple and straightforward, and it's easy to read and easy to maintain. So what's terrible? Complex data flow. I cherry-picked the snippet from an open source project that I'll leave nameless. The above calculates the selected index of the tab bar in the app, I think. It's mostly indecipherable to me. I asked some more people that are more familiar with reactive programming than I. It took a minute to figure out what was actually going on too. So, not just me. So, you can't have a large app and have complex data flow and difficult to parse, difficult to read code like this. Maybe we'll see less boilerplate in reactive programming in the future, but we're not there yet. So less files is better than more files. So I think originally I showed you there was 6,000 files in the whole project. That means long build times. So you do have to think about breaking up your code into files so that they're compact and less code, but less files as well. So an architecture that turns, say, a 500 file module into a 2,500 file module, probably not a great decision. So like architectures like Viper and stuff, just like break out controllers into like many, many files. Code spreads across many, many files. But if you do that across an entire module, your compile times go up. So this is actually an issue that you actually come across in large apps that you don't come across in small apps. Local state. Local state and using techniques like dependency ejection make state mutation explicit. Explicit state is much better than implicit state or yes, and it forces components to communicate through protocols. So it makes that clear as well. So global state is terrible when you have a large app. Global state is terrible when you have a small app, but it really, really exasperates when the larger you get. There are cases even in Cocoa where global state is introduced. Instances like shared instance, like your location managers and stuff like that. This scatters state change throughout the app, and it intertwines dependencies. This makes unit testing much harder. So if some state can change behind your back, then it turns into a big mess, especially in large apps. Debuggability and small call stacks. Debuggability, I'm not sure if that's actually a word. There are frameworks that you can add to your project. And the first thing that you should do is take the sample code that they show in their GitHub README and just set a little bit of a breakpoint and see when it hits. How deep is your call stack? This is a good test because simpler call stacks, shorter call stacks are easier to debug. The flow is much easier to understand. And when you have a large app, you need to understand the flow. You need to understand where in the call stack that you are to be able to debug issues in a very large app. So there's been 5 big initiatives to refactor code to be smaller and more simple over the years. So the first initiative was moving from Objective-C to Swift. This is a multi-year initiative, and it's happening slowly. As I showed you in the lines of code count, it's 2 lines of Swift to every line of Objective-C, right about now, and slowly we'll see more and more of that. Also went from a monolithic architecture to a modular architecture. What does this mean? Broke out the big app into smaller projects. I'll get into that a little bit later. The third initiative was moving from an old legacy REST API that was built for the desktop web to a newer GraphQL API. And there is an initiative going on right now to move from table view controllers to collection view controllers. The big 5th initiative that I'm not going to totally dig into is a redesign. So a big win in having a small, simple app is actually having design on board. Having standard and uniform buttons, labels, fonts, colors. The way your constraints are laid out becomes uniform. Patterns can be extracted and used once. So really focus on having design on board as well when thinking about your architecture of your app. So the first initiative was a multi-year initiative going from Objective-C to Swift. There is way less code now, and there's less language level bugs, mostly. Mostly. So a large case of Objective-C bugs that we used to see was around nil. So the web service would return unexpected data. When you have a very large e-commerce app, you may have tens of thousands of third-party sellers with millions and millions of different SKUs. And at any time, a product in the web service is terribly, terribly broken. So you can expect your views to be broken because some data from the web service is not what you expect it to be. It could be of wrong type. It could be missing. It could be renamed. Very complex data. There's also very complex product types. And some of that complexity was dealt with optional protocols and using stuff like response to selector to see if we could actually run this logic or expect this data to be there. And there was just cases of, you wouldn't find at compile time, you find at runtime on a product that maybe doesn't even exist yet. So a lot of bugs were around that. There's just a whole lot of complexity. The more code you have, the more complexity you have, and a lot of bugs arise just due to sheer complexity. So the Swift bugs that we've been seeing at the language level, mostly around optionals and mostly around force unwrapping. We were learning Swift on the fly. We made mistakes. We were very early on the Swift train, probably Swift 1.1, 1.2. So yeah, we were learning on the fly. Boy, did we make mistakes. But in general, the transition from Objective-C to Swift has made the code smaller and simpler. This may or may not be the most controversial thing that I say today. Moving to Swift was a net win. Feel free to cheer or jeer. The next big shift was from moving from a monolithic architecture to a modular architecture. This involved breaking up the code into modules that could be plugged in when the app launches, and a router to navigate between these plugins. So a modular architecture makes each module smaller and simpler, and it reduces the surface area of how modules speak to each other. So there's a plugin protocol, a pluggable, and it generally handles the startup and shutdown of plugins. And plugins generally do need to know about the application lifecycle. So if an app returns to active or goes into the background, stuff like that. Also stuff like push notifications may need to be forwarded. plugins do need to communicate amongst each other, and there's a supervisor that manages access to other plugins. And you can query the supervisor for the API for each plugin. And you can pass data or call a function on another plugin. So here's an example of the product API and being able to grab product data. So search or the home screen might need to see a product to show it. A weekly ad might need to show that, stuff like that. So secondly, moving to a modular architecture is a router. So it's responsible for navigating and presenting views. So it's fairly straightforward to register a route. And a route looks very similar to an NS URL, or a URL in Swift now, I guess. And the way you route to it is through a URL string. Looks very much like URL links that launch your app. So that's the general modular architecture. Let's get back to the product module and really dive deep on that. So the legacy client-side networking features were written way back in 2011. They were written before NSURL session was developed. I believe NSURL session showed up in iOS 6 or 7. I don't even recall. And we had to rethink the way Objective-C blocks and Grand Central Dispatch queues are used. And legacy server-side networking, the original web service was targeted at the desktop web. It was very slow, and it was the responses were very fat for certain cases. A product that is a bundle with many other products that are sub-products may have a JSON response that is many megabytes large. JSON that's many megabytes large. And the backend orchestration service that orchestrates this product to you and responds, it may take many seconds to respond. And a lot of times, the response may time out. At the orchestration layer, one of the services that it depends on may time out. So you may only get half responses. So today, we move from a REST API to a GraphQL API. So there's the ability to query for just the JSON that you need. So maybe you don't need additional hero images, or maybe you only need hero images and you don't need thumbnails. So that's an example of thinning up the response that you get. And fields are kinda typed in the way that JavaScript is kinda typed. So REST versus GraphQL. It hasn't been all upside. So GraphQL doesn't expect queries to be versioned. Basically, a whole different web service is used to version requests. So basically a side channel. A configuration web service that is mainly used for A/B testing purposes. That's what we use to version our GraphQL schemas. Versioning is kind of like A/B testing, right? Right? So we did have to hack together versioning. All GraphQL requests are posts rather than gets. Post kind of breaks. GraphQL posts kind of break HTTP semantics. One of the semantics that it really breaks is caching. HTTP post requests cannot be cached, whereas gets can be. Caching is hard. There will be bugs. I have personally written caching bugs. Everyone assumes caching is, oh yeah, we'll just cache that. It will always catch up to you. And really, there are only 5 GraphQL query variants right now, and only 3 different clients. There's iOS, there's Android, and there's the mobile web, basically. Maybe all of this extra complexity isn't really required. Maybe we don't actually need all this flexibility. Sometimes hard-coded code is the correct thing to do. Open question. Ask me in a year. So this is a very open question, if this was a good decision or not. Future networking. So we can exploit the GraphQL schema to optimize payload size. I think we can squeeze down responses even smaller. And who owns networking? This is usually, each app I've seen in the world does it slightly differently. Right now, the view model layer owns networking. I think this is terrible. Networking and view models are very coupled right now. This makes unit testing hard. I'd prefer to see hard boundaries at the networking, at the serialization, and at the view model layers. And they should communicate through protocols, and they should be like individually testable. Right now, they're not. They're really dependent and coupled. So that's in the future another initiative that we have to go through. So speaking of serialization, we went from Objective-C style serialization to Object Mapper, the Object Mapper framework, to using Codable in Swift now. Let me talk about that. So originally, here's what serialization looked like in Objective-C. So a product model was of type model object, and a model object lets you hand the system a dictionary that mapped to keys. So that's what is happening there, mapping dictionary for data. So the mo_key keyword that you see there, that's a macro that performs magic. In C, whenever you have to reach for a macro, that means that there's something missing in the language. Also take a look at that isValid model function. Serialization validation is a two-step process. So things get serialized, and then a check is done for validity. So the next step was to move to Object Mapper. Object Mapper uses operator overloading to encode and decode JSON types. Operator overloading is definitely an improvement over macros. I know people are not fans of operator overloading, especially people that come from a C++ background, but I think this is a perfectly cromulent use of operator overloading, especially when you're transitioning from macros to operator overloading. This is a use case that you should be reaching for. And take a look at that optional initializer. So validation has become a language feature rather than a function call. You can't get an invalid object, right? The initializer just fails. The next step was to move to Codable. This happened actually fairly recently. Coding keys are flexible enough for serializing data. And notice the throws in the init initializer there. So that's another language feature is used for validation. So that's great. That's a language level feature. But the best thing about Codable is that it's integrated with the compiler and the toolchain. The toolchain can generate code for you. And if your type conforms to Codable and each property conforms to Codable, you're done. Like all that boilerplate is written for you. And this is much smaller code. Less code is better code. So let's move on to the controllers. So the legacy controller was and is still a fat UITableView controller. By fact, I mean there's like the kitchen sink is in the view controller. Conforms to too many protocols, and it picked the wrong abstraction. So a product view may have many sections. It can have 30 to 35 sections. And an abstraction was each section of those was also extracted into a section controller. This ended up with a lot of boilerplate code and dispatching to these section controllers. And it just moved some section controller code into other section controller code, and there's like a lot of overhead of passing state back and forth. And there's been UITableView scrolling performance issues, especially if there's multiple HTTP requests. So some of the product might show up and some of the product might show up later. Like how do you do reloads with good scrolling performance? So this is the largest chunk of Objective-C left in the app. And it's slowly being moved to Swift. So one feature of Swift that's helping is extensions. So strategic use of extensions to break out protocol conformance. So like if there isn't a case where a plain old Swift object can be your delegate and then like somehow communicate back and forth between the controller, if it can't be extracted, extension is a good tool to reach for. So the current controller initiative is going from a UITableView controller to a UICollectionView. So there's a modern API that improves scroll performance. So UICollectionView supports cell and data prefetching. So cell and data prefetching has really been a win for us. UICollectionView layout is more flexible as well and lets you extract code from a layout code into UICollectionView like flow layout classes. So the current controller initiative is also going from a view controller to a view. So there's been a lot of controller code that's been extracted into plain Swift objects. And CollectionView layout code and CollectionView layout attribute code has been extracted. And the data source and the delegates has been extracted. We learned from the section controllers of the legacy that this was not a good abstraction that led to clear code, led to too much boilerplate. So, but extracting data sources and delegates has been a win so far. So let me wrap up. As a reminder, here are the big 4 initiatives that allowed the legacy e-commerce app we've been working on to transition to a smaller and more simple code base. The first was moving from Objective-C to Swift. The second was from a monolithic to a modular architecture. The third was getting to use GraphQL to shrink down that payload size. And the current initiative, moving to a collection view. In conclusion, I propose that good iOS architecture is small and simple. And on the right, that is my English Mastiff, Stanley, who is neither small nor simple. Thank you. Questions? I believe the mic is headed in your direction. Oh, sorry.
Hi, thank you for your talk. My question's on your transition from Objective-C to Swift. How did you make the decision where to start? Because I'm guessing there are probably thousands of files, and you can't just pick one at random and say, I'm going to just change this to Swift, because you end up going down a rabbit hole.
So feature dependent, really work with product management with which features are coming up next. And then the developer, it's left up to the developer. We assume the developer has good taste, right? You have to really trust your developers. Is this new code for a new feature from scratch? Yeah, probably Swift. Is this an extension of a current feature that now that we have, we had feature A, now we extend it to A1, A2, A3. Now the developer has to make a decision. Do we rewrite A and add A1, A2, A3, or just keep writing Objective-C? That is a case-by-case basis, but good taste, right? That's a decision that has been made by the developer.
Since you're working with product managers and designers, storyboards, nibs, defining your UI in code, I've found that designers can actually understand nibs sometimes.
I agree with you. The rest of my team does not agree with you. I'm a fan of storyboards. I prefer to lay out UI in storyboards. For most views, there are cases where you have to lay out in code. And a good designer you can go back and forth with. And also, now that there's a crazy number of screen sizes, and being able to quickly switch in the tool between screen sizes, huge win, right? But there was a team-level decision made that constraints would be laid out in code. One of the main reasons is in e-commerce, you don't just ship features. Everything is A/B tested. Everything is A/B tested because you might change the alignment or the color of something, and now conversion rate has gone down 0.x%, and that 0.x% conversion difference means millions of dollars, which means you miss your quarter. So trade-offs, right? So like I prefer UI laid out in UI, but like I'm not hard on that because in this specific case, in code is probably better. Just the way that A/B testing works and the way we have to compose all of these views.
Hey, great talk first of all, and so I see that you like poked at Viper, for example, and I totally agree with you. I don't like this super complex architectures, and more importantly, I don't think personally there is an architecture that serves all. I tend to prefer to change the way I do a part of the app or application depending on what it has to do. So I was wondering if you have like a book of recipes that you use inside the team or the app, or you trust the developer again on each subsystem or?
I was probably a little bit unfair picking on Viper there, but it is like the most obvious example of many large like files, right? You can document some of this stuff, but really communication with your team is the way it's going to work. And your architecture decisions should be simple and explicit enough that it should kind of be obvious the way you lay out views, the way a controller works, the way actions, you dispatch to actions. It should just like, it should be uniform. And so when you see a ticket come in from your product manager to build something out, you should be like, okay, I'm going to do this architecture change and this and this and this and this. I know how view is going to be laid out. I know how the logic is going to go. I know how the view model is going to be bound. I know how I'm going to do unit tests. Like it should just really guide you, right? So that's like I would say a definition of a good architecture. It kind of makes it obvious, like where your code should go. I don't know if that answered your question.
Sorry, no, because I taking a bit like I totally agree, and the part of the question was also if new team members comes in, for example, and do they have the freedom to choose the architecture, or do you tend to help them comply to something you already used in the past? Because I had the very same this kind of problem with new members came in, and they were like 15 years younger than me, yeah. And so they were like jumping on board all these new architectures and stuff, and so I had to kind of push that enthusiasm back a little bit. And
so I would say this is a people and process topic, right? Having good stand-ups, having good tickets that describe the features, and communicating well every single day, having a pull request process where code is reviewed. I find that is generally better than having documentation written down. But yeah, I haven't seen great up-to-date documentation ever about how an architecture should be laid out. It's just a lot of it is verbal communication and your code review process, right? There's two right there.
You mentioned like that you have different plugins, has like modules. Are they actually separate targets, or it's like just the way you organize the project?
One target, multiple projects in like a workspace.
Okay.
Yeah.
So you talked a bit about going from monolithic design to modular. The thing I see with almost every developer who tries to do that is they pick the wrong abstractions and they make things much harder to work with. How do you pick the right abstractions?
It's like a lot of these, the answer to a lot of these questions is experience, taste, wisdom. Like, there's no good hard and fast. And we've been having this monolithic versus modular architecture discussion for decades, right? This was the original Linus Torvalds, Andy Tannenbaum, Minix versus Linux debate from like 1992, right? So like, where like software is complex. Where do you put the complexity? And if you're moving to a modular architecture, the complexity moves from the code into the communication between the modular bits of the code. So yeah, you have to taste, wisdom, experience to understand where you're going to put this complexity. There's a question right there.
Hi, good afternoon. I have just one question. Given that if you have an app with a large number of files, what are your recommendations in terms of organizing the project files? Do you like group them by function, by feature, or how do you approach that? And with that approach, why did you choose that approach in your team?
So that's changed over time. So we had this section controller abstraction before, and the project was basically grouped by section. So title section, hero image section, price section, variant section, add to cart section, bundle section, collection section, about this item section, review section. So it was just section, all the way down the page. And it was similar to the way you would see a product on your iPhone. It's very similar now. We've gotten rid of a lot of this boilerplate. So now there's just one controller and there's helpers, like all the code that's extracted for that controller. So like all the extracted code in a folder. Boom, 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 boom. So you can quickly see that. And now moved away from this section controller abstraction to just flat out simple collection view cells. So there's just 30 collection view cell files. Boom, 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 boom. And just in the same order that you see them on the product page. Then view models and networking, other folders. The view models are getting very large. We need to rethink that. So yeah. Anyone? We have both. Yeah, we have both.
So you made a decision to move to Swift. Swift is changed a lot over the
It has.
times. Is it not a lot of time every time to follow Apple to make the changes? And with Swift 5, you probably have to do it again.
Yep.
But is that not? Did you calculate the man hours in that and versus maintaining Objective-C?
It is generally, so there's many modules in the app, and there's also an end-to-end core team. So the end-to-end core team generally does a first pass of getting everything, at least try to get to a compiling state. And then each module goes next after that. It's a process that needs a lot of planning, right? Because now you have to plan with your release managers as well, right? You have to plan with your end-to-end QA team.
But would it be possible to get the same gains by refactoring the original code without moving to Swift?
Refactoring the original code, all of it.
Or every part that you touch, like you now, when you touch it, you move it to Swift instead of refactoring and improve it.
Maybe. So at the end of the day, the customer pays our bills. They have money. We have products. We give them products. They give us money, and if we do a good job, we get to keep working. So we got to think through what is the best decision for the customer. So it might be yes, refactor right away, or it might be have a plan in place to do this over 2 quarters or something.
Okay.
Just pulling a number out of my hat. Yeah.
I got a question.
Yes.
So you say you're moving to a lot of the new code and also old code to Swift. What do you see about compile times, and like, are there any things that you've seen or done that kind of helps improve compile times with Swift?
Yeah, there's a hacked together script that actually caches a bunch of compilation. It's voodoo magic. I have no idea how it works, but it mostly works. Yeah. So when you get that large, you're trying to improve compile times. It caches off a bunch of projects into like a static library and then like links them together. But that's not. It's meant for developers to like quickly iterate, and it doesn't actually. That's not the way like nightly builds or test flight builds or the App Store builds get built. But like this is a quick way for developers to keep moving. It's voodoo magic. Yeah, I have that.
And just to follow up, can you kind of allude to like your testing? Like, do you use like snapshot tests? Like, what kind of testing is it?
So we started with all unit tests, and we test everything in the view model layer. So there's data that comes off the wire from your web request. There's a bunch of calculations that have to be done before it displays the UI. So those are all unit tested. We could probably do a better job of that. As I mentioned, networking is a little bit intertwined with the view model layer. So A, unit tests. B, there are UI tests. We use a thing called Appium, and we share UI tests across iOS and Android, and it uses the accessibility system. So the same UI test written in JavaScript exercises both the iOS and the Android app. I see a question at the back over there.
This might have been asked before, but do you have any bridging between Swift and Objective-C that you still need to maintain?
Sorry, can you ask that question again?
So you've migrated from Objective-C to Swift. Is that correct?
Yeah. Not mostly. There's still. It's like I could go all the way back. It's about 2 lines to 1 line of Swift. Way back there. Right about there.
Okay.
Yeah. So that's about 2 to 1, right?
Okay.
About.
So you still have bridging back to Objective-C.
Yeah.
For like some low level type of things that you didn't want to refactor and pull into Swift.
I wouldn't say it is a low level versus high level stuff. There are a bunch of shared libraries that help with serialization, that help with networking, that help with archiving, that help with dispatching that are Swift. So there's a lot of low level stuff that's also Swift now.
Okay.
Yeah.
So you still have a little bit of Objective-C code. Do you think you would imagine that you would go completely over to completely 100% Swift? Or
eventually?
Okay.
Ask in 5 years?
Yeah, right.
What is it, 160,000 lines still? So maybe, I don't know, 5,000 lines a month get converted over or something?
Okay.
I don't know. Like, it'd be interesting to see the pace at that change is happening. I haven't done that.
Okay. Thank you.
All right, so this is going to be our last question.
Hi, do you have any UI tests where you stub the server request? So if the server is like having issues, then your UI test will pass?
Yes. So the Appium UI tests, they don't hit the network. There's some node server magic that serves JSON responses from a directory on the same machine, so it doesn't hit the network.
So is there an automated way to generate that JSON, or do you have to generate it for each network request manually?
It kind of works like you do. So we usually use a tool called Charles Proxy.
Okay.
when we are even when
Record
we're
the
like
network
developing
requests.
to watch the JSON on the wire coming between. So if we're writing, we just like copy it out of and put it in the directory, right? Yeah.
Cool.
All right, cool. That's it. Thank you very much.
Thank you, everybody. My Twitter handle and email is on the bottom of the slides. Feel free to contact.